Hi guys, in this video we will discuss about KNN, that is K nearest neighbors machine learning algorithm. It is widely used for classification as well as regression, and it is one of the simplest algorithms of machine learning. Mostly this algorithm is used for classification. So these are the steps we are going to follow. So let us import these libraries. So we have imported NumPy, Pandas, Random, and matplotlib. Now here we are going to generate 10 random values and assign those values to a variable called x. So here we go. So these 10 values have been generated and assigned to x. Likewise, we will generate 10 more values and assign it to y. Now we are also going to generate 10 values within the range of 1 to 2, and just see, this is how it is. So there are 10 ones and twos. Having created x, y, and g, we are going to create a data frame. So this is our data frame. So it has got three columns: x, y, and grp. grp stands for group, or we can also call it as class. So what we have done is, for each and every data point, randomly we have assigned one of these two groups, either one or two, and it has been done randomly. Now we will create a sample x and y, that is test data point. So our test data point is x is 6 and y is 9, and we are assigning 3 to k. And what exactly is this k? We will discuss this in a moment. Now, for this x and y, for all these data points, we are going to generate a scatter plot. Now, all these blue data points are pertaining to training data set, and this red data point pertains to our test data point. And here we have used two symbols, star and plus, to denote which category these data points belong to. So there are two categories. So plus sign denotes category 1, and this asterisk denotes category number 2. Now what we will do is, we will start calculating distance between each and every training data point with respect to this test data point. So here we are doing that. We are using Euclidean distance method to calculate the distance. So here we go. Having created distance, now we have created one column in the data frame and assign all the distances pertaining to each and every data point. So here this column is showing us distance, right? Now we will sort this data frame according to this feature, this column, and sorting will be done in ascending order, meaning the least value over here will come on top and the maximum value will go down, right? So we are sorting on distance, and once we have sorted, this is how it will look. So this is the list value and this is the highest value. Having done that, now we will extract 3 rows from this data frame, and that is precisely what K is talking about, and we will discuss why we are extracting. So let us first extract 3 rows. So we have extracted 3 rows, and that 3 is denoted by the value of K. Now next, see here, when we have extracted these 3 rows, 2 rows pertain to group 2, whereas 1 row pertains to group 1. Now we will have majority voting, meaning we will see which group has got more frequency. Obviously, group 2 has got 2 records, whereas group 1 has got just 1 record. And here, what we are doing is we are extracting the group which has more frequency and putting in another data frame, and the data frame name is df underscore g. Okay, and this is what df underscore nn, that is nearest neighbor. 3 nearest neighbors. In other words, these are the data points which are nearest to our test data point. Now, how many data frames we have? One data frame by the name df has got all these 10 data points, and this df underscore nearest neighbor nn, it has got 3 rows. They are 3 nearest neighbors, and this df underscore g has got 2 records, which means this group, the group number 2, has got more frequency. So what we will do, we will say that our test data point belongs to group 2. That means the classification is being done. We will classify our test data point to be pertaining to class 2. Okay, now how we can do that? So let us not draw all the scatter plots now. Now, first of all, we are plotting for data, this df variable, right? That data frame. So here we go. 1 second. We will do that. Yeah. So these are our 10 data points. Now let us bring in our test data point. This is test data point. We have already determined 3 nearest neighbors, and we are going to mark those 3 nearest neighbors. How? Just see. We will draw a scatter plot for dfnn. When we do that, see, 1, 2, 3. These 3 data points are nearest, and that is how it is being reflected by this square with color yellow. Now, see, these are 3 data points. Now we will go for majority voting. Now here we have group 2. 2 data points are pertaining to group 2, whereas 1 data point pertains to group 1, which means we will classify this test data point to be belonging to this class, this group, or this category. That is group number 2. So let us see. Now what we will do? We will put a green circle over here, meaning that classification has been done and this is going to belong to this class. So this is how. And here we can also print df underscore g. Here we are depicting graphically. Here we are showing the actual data points, right? Here, see, group 2. So these are the data points. They pertain to group 2, and accordingly, we are considering this test data point to be belonging to this particular class. Done? So that is how it works. Now, see, we have written our coding in so many cells. Fine, that was only to explain each and every line. Now what we will do is we will consolidate all these lines in one particular cell and we will run it. So we are consolidating over here, and then we will run, and we will run and draw two graphs. This one before distance calculation and after distance calculation, which means this will be our final graph, right? So there will be two, and we will place them side by side. So here we go. Same thing, nothing has been changed. There are two graphs. See here, these are training data set, and this is test data set. And now here what we are doing, we have already calculated distance and we have determined class. Now this is all about considering three neighbors. We can consider 5 neighbors, we can consider 7 neighbors, we can consider 9 neighbors. Always the value of k will be an odd number. And you may wonder why odd, why not even? Look, if we will consider nearest neighbor to be odd, then definitely one category will win over the other. If we'll take even neighbors, it might happen that this test data point is closer to, say, if we take 4, it is closer to 2 data points pertaining to category 1 and 2 data points pertaining to category 2. Now, how you are going to classify this test data point? It will be difficult. Hence, we will always consider an odd number. Next, what we are going to do is we will use the same data set and the same test data point as well, but we will increase our neighbors. First, we will consider 3 neighbors, then 5 neighbors, then 7 neighbors, and then 9 neighbors. Okay, so here we go. The same data set, nothing is going to change. Okay, everything will be same, and we will run this. I think this is not needed. Here we go. Okay, see 3. When we are considering 3, category 2 is winning over category 1. Very good. Now here see what happens. This and this. We have category, when we are considering 5 neighbors, there are 2 data points pertaining to category 2, whereas there are 3 data points pertaining to category 1. So we will classify this test data point as class 1. Okay. Now let us consider 7. When we are considering 7, again category 1 is winning over category 2. So we will consider this training data point to be belonging to category 1. That is about 7. Now this is 9. Now what happens? Here again it has changed. Now we will classify this training data point to be belonging to category 2. Just see, as we are changing the number of neighbors, our classification is producing different results altogether. See, for 3, it is saying category 2. For 5, it is saying category 1. Again, for 7, it is saying category 1. But when we are saying 9, again, it is saying category 2. So this is how KNN classification is going to behave. Now, next, what we will do is here we are going to increase the number of training data points. We are considering 50. Everything else will be same. Nothing other than increasing data points. We are not doing anything. Everything remains same. But since the data will be very condensed, we will not be able to sometimes count, right, easily. So what we will do, we will print the value of df underscore g. What does this mean? Look, df underscore g is going to hold the category which is winning when we are voting, when we are deciding about the majority, right? So though it will hold either it will hold either group 1 data or it will hold group 2 data. So let us go and just see. So here we go. Let us run this. Okay. K3. Okay. This is before calculation of distances. And once we have done, we are telling that for 3, group 2 has 1. Hence, our test data will be considered to be belonging to group 2. Next, now K5. Now, here also it is saying the test data will belong to group 2. Just see, you can see 1, 2, 3. It's 5, right? 1, 2, 3, 4, 5. Only one data point belongs to group 1. Now, next, 7. Again, group 2. Just see, 1, 2, 3, 4, 5, 6, 7. Right? Again, group 2 wins. Then 9. What is happening? Same case. Group 2 is winning. 11. Here also, group 2 is winning in all the cases. So now what we will do is, let us run this again. Okay, so we can do one thing. Let us not overwrite. We will copy this entire cell and paste here and run it. Now, why are we doing this? We want to see whether this nearest neighbors are going to change or not, right? I mean, not exactly nearest neighbors. We are going to see whether this association with respect to category 1 and 2 is changing or not. Here, across whether we consider 3 or 5 or 7, 9, 11, every time it is belonging to group 2. But it may not be the case always. Just see. See, 3, 2, 5, 2, 7, 2, 9, 1. This is interesting, right? And then let us see 11. 11, what is happening for 11? Okay, 11 is also 1. So this is very interesting. This is the most important part of KNN. Look, when we are considering 3 neighbors, group 2 has 1, which means this test data point will be classified as group 2. Group 2. Very nice. See, 5, group 2. Group 2, fine. 7, group 2. Look, see how this is 4 and group 1 is only 3. And we are always considering odd numbers. So 3 is to 4. So 4 is going to win. Here 5, 3 is to 2. 3 is going to win. Okay, now next 9, group 1. Look here group 2 was winning, and the moment we increase our neighbors by 2, now it has become 9. Because of that, this and this got selected. See, this and this got selected, and hence 1, 2, 3, 4, 5, that is group 1, and 1, 2, 3, 4, that is group 2. So who has 1 here? Group 1. So now the test data point will be categorized as belonging to group 1 if we consider k as 9. And same is the case when we consider k as 11, again group 1. So this is all about the classification so far as k and n algorithm is concerned. So we can maybe in upcoming video we will take some practical example and just see how we can classify our test data point or data points using k nearest neighbors algorithm. Thanks for watching, and I will see you in the next video.